Hello, welcome to our hybrid cloud migration demo video. Before we begin, let me provide some background on how we developed this feature. Early on in the development process, our customers asked us to help them pursue a multi-cloud strategy for Kubernetes. Specifically, they wanted the ability to quickly utilize a third-party cloud or Kubernetes service to protect their business. So we went to work in this feature, or more accurately, features were born in version 2.0 of TrilioVault for Kubernetes. To get into the demo, let's first show you the environments that we're operating in today. One is on-prem Kubernetes, and the other is Amazon EKS, which is Amazon's managed Kubernetes service. For the demo, we'll be restoring an application and its persistent volumes in EKS that was originally running in Upstream Kubernetes version 1.18. First, let's take a look to make sure that I'm not trying to fool you. Here from the kubectl config, you can see the cluster on the left is Upstream Kubernetes, and the cluster on the right is an AWS EKS cluster managed by Rancher. Just to be certain, let me show you the EKS cluster in the AWS dashboard. There it is, Rancher EKS 117. As Upstream Kubernetes will be the source of our backups, let's switch over to its command line. In the Trilio demo namespace, we have several resources comprising a user portal application. This application is comprised of a front-end Nginx replica set with a single node pod running the MySQL database. Additionally, there are several Kubernetes native resources tying these pods together. Specifically, we have two services, one for Nginx and one for MySQL, and a secret that is responsible for MySQL authentication. Also, MySQL is consuming a single PV provided by the Kubernetes CSI. Now that we've seen the application we'll be backing up, let's take a look at how TrilioVault extends the capabilities of our cluster. First, let's take a look at the TrilioVault target CRD to see what's available. Notice that this is done via kubectl command, and TrilioVault integrates with the Kube API for a native self-service experience. As you can see on the screen, the target CR that we've already applied to the cluster is an Amazon S3 repository that we'll store our backups in. Next, let's take a look at the TrilioVault backup plan CRD, which is a plan to protect an application. We applied this backup plan earlier to protect all of the resources, including the PVs, of our user portal application. Notice it will be storing those backups in our AWS S3 target. For the next step, we need to find out what point in time backup we'd like to use for our backup plan. Let's select the latest available backup, the one we've highlighted here. From this backup, we'll need to grab the value from the location field in order to specify it in our EKS cluster during the restore process. We can run a single command to grab the value from the backup, as you can see on the screen. At this point, we've completed our effort in the Kubernetes cluster. Let's switch over to EKS, where we've already installed TrilioVault. Now that we're in EKS, let's check the namespace that we'll be restoring to so we can be sure there's no applications running. Looks like the EKS migration namespace is empty. The next step is to make sure that the same AWS S3 target is mounted in our EKS cluster. We have that target in an available state, and we can proceed with the restore. Before we actually begin the restore, let's take a look at how we create a restore custom resource for the different cluster. Here is the YAML file for the restore. Let's take a moment to understand the problem and how we've solved it. Since we're moving from on-prem Kubernetes to EKS and AWS, there are resources like storage class that have to change in order to bring the application to a running state. We've considered this use case due to our extensive background in cloud-native platforms and developed a method to transform resources during the restore. This restore will take the original storage class for the MySQL PV claim and transform it to use the GP2 storage class. Now we're ready to apply this YAML file to the EKS cluster. Here, we can see the restore CR has been created and we're off and running. To save you time, I'll compress the time frame of the restore, but it completed in less than a minute and a half. Recoveries are all about getting the application up and running, so let's check our EKS migration namespace to see if the application's back up and running. It looks like everything is there and healthy. I do realize that this will probably seem like a trick to longtime users of Kubernetes. So let me show you that I'm still running these commands against the EKS cluster. And there you have it. An on-prem K8s to EKS restore in less than 2 minutes. Thanks for taking the time to watch our demo video. Again, I'm John Tobin. Have a great day.